Hi, everybody. I hope everyone is doing well. I am going to try to teach you sort of like I would in class. You'll notice my PowerPoint looks like something I would do. Um, so I'm going to have the directions on Google Classroom, but um, you're going to be taking notes on the things that I say, and I'm going to tell you what to write down pretty much. We're moving into Newton's laws. If you've never done them, Newton's three laws of motion are scientific laws that sort of tell you what's happening in the world, kind of give you some insight as to what's going on. So Newton's three laws, the reason I have these GIFs, you'll sort of see as we go on, they make a little more sense. Um, you know me, love a good cat GIF. Okay, let's move on. Okay, so here are 4 vocab words and definitions I need you to write in your notebook. Like we've done with another assignment, I'm gonna have you physically write it in your notebook, and then you're gonna take a picture and show me and upload it to Google Classroom when I make an actual assignment for it. So momentum is the strength or force that something has when it is moving. Um, Speed, the rate at which someone or something is able to move or operate. Velocity, the speed of something in a given direction. And acceleration, increase in the rate or speed of something. And if you need to slow it down, you can pause me, you can stop and write stuff down. I know I'm going to put it on YouTube, so you can actually slow me down speaking, I think. Pretty cool. Okay. Okay, so normally I would have you do a foldable, but I'm not going to do that. You're going to just take notes, and I'm going to have you do other assignments and stuff, but I'm not going to have you do a foldable. You're missing out, clearly. You're missing out. So if you've never heard of Sir Isaac Newton, he, one of those brilliant and awesome scientists and mathematicians that ever lived. He's most known by most people for his laws of motion and laws in physics and math. Um, but yeah, there's whole documentaries on him. So obviously that's not all he's known for, but you know what I mean. Okay, so Newton's first law of motion. An object at rest will remain at rest unless acted on by an unbalanced force. I'm going to be moving my head around because I'm going to be in the way. So an object at rest will stay at rest, and an object in motion will stay in motion unless something stops it, unless something moves it. So you have like a picture frame hanging on the wall, and it's going to stay there unless something acts on it. Like if someone were to hit the wall, or gravity takes over and it falls off from what it's hanging onto, like a nail. There is a natural tendency of objects to keep doing what they're doing, and objects in nature resist change. So things don't necessarily change on their own. There has to be some other force that's going to stop it or change it. A really good example is the reason why you wear a seatbelt. When you are doing 70 miles an hour on the 95, you are doing 70 miles an hour in your car, and your body is also going at 70 miles an hour. So the reason you wear a seatbelt is because if you were to hit something or someone hits you, your car is going 60 miles an hour and your body's going 60 miles an hour. So if the car stops, your body still wants to go 60 miles an hour unless something stops it. Seatbelt. And what happens if you don't wear your seatbelt and your body wants to go 60 miles an hour through your car? Not a good time. Not a good time. So law of inertia, it's also called first law of motion, is the reason why you need to wear your seatbelt. Your body wants to keep doing the same speed it was doing in the car. Okay, yeah, there's an example. And skateboarding, if you've ever hit a rock skateboarding or rollerblading or on something with wheels and you hit a rock and it stops and you don't see it coming, and you what? You fly forward, you fall off, right? Because your body wants to keep going at the speed. Even if it was only 3 miles an hour, it wants to keep going at that speed. So second law of motion, the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate that object. That's actually second nature to you. You know this already, but you don't think about it. If you were to see 2 carts, and one of them had 2 Gatorades in it and one of them had 400 Gatorades in it, which one's got more mass? The one with the 400 Gatorades, right? Because it's that that cart full of Gatorades is going to be heavier. Which one's going to need more force to push? the 400 Gatorade cart, right? So the greater the mass, the more force you're going to need to accelerate the object, okay? So the more mass something has, the more force you're going to need to move it. Simple, easy. Which would be harder to push? A bike or a car? The car has more mass, and you're going to need more force to accelerate it. That should be simple enough for you, simple enough. So the mathematical equation that goes with that is force equals mass times acceleration. So the force needed is equal to the mass of the object times the acceleration, okay? So let's do a little mathy math word problem here. Let me move my head. Okay, so here's how it works. JJ's car, which weighs 1,000 kilograms, is out of gas. JJ is trying to push the car to a gas station, and he makes the car go 0.05 meters per second squared. Using Newton's second law, you can compute how much force JJ is applying to the car. Okay, so we got force equals mass times acceleration, right? So we've got F equals mass. What's the mass? Do that thing like Dora where I just stare and blink at the camera. 1,000 kilograms. Good job. So force equals mass, which is 1,000 kilograms times 0.05. That's the what? Acceleration. So force equals mass times acceleration. So F equals 50 newtons because 1,000 times 0.05 is 50 newtons. The unit for force is newtons. Okay. So when you hear force equals mass times acceleration, you're like, what? But obviously it's super simple. You're learning. Okay. Okay, Newton's third law. For every action, there's an equal and opposite reaction. I'm sure you've heard this before. And this is called Newton's cradle, which is a really good representation of every action. There's an equal and opposite reaction. If you were to play with Newton's cradle, which I think I have them in my classroom, who knows if we'll be back in my classroom for me to show you. But when you move a ball on one side, it moves the same amount and with the same gusto on the other side. So if you were to lift 2 and let it go, it would hit 2 on the other side. It's equal and it's opposite. Another example of equal and opposite reaction is if you when a rocket blasts downward, the action is the rocket's engine blasting downward towards the ground, and the reaction is it going into the air. So that's the equal and opposite reaction. There we go. Rocket works. The action is to push down on the ground with a force, its powerful engines, and the reaction is that the ground pushes the rocket upwards with an equal force. And just to kind of remind you, you're supposed to be taking notes on all this, so feel free to pause. You should be writing down the definitions for 1, 2, and 3. And we can go over it real quick. Again, let me move my head. Whoops, gave you an answer. All right, magician pulls a tablecloth out from under the dishes and glasses on a table without disturbing them. Which law is that? So it's not, the items on the table are not being disturbed. So that's 1. 2, a person's body is thrown outward as a car rounds a curve on a highway. Which law is that? Remember that whole seatbelt thing? That would be number what? What? Uno. Okay. Okay. A soccer player kicks a ball with their foot and their toes are left stinging. Which law would that be? 2. Picture is hanging on a wall and doesn't move. Which thing's about not being disturbed? It's 1, but I'm in the way. A picture is hanging on a wall and does not move. That was 1. And then a soccer ball accelerates more than a bowling ball when thrown with the same force. That's probably 2. Boom. Okay. Just a GIF, because you know that's how I roll. Okay, that is pretty much it for me right now. You can go back and pause things or go back and speed it up, whatever you want to do. And your actual assignment will be on Google Classroom. I hope everyone's doing well and everything's okay. Okay. Okay, bye.